Let's check two more graphs here that are actually graphed for us and see whether or not these are functions. All right, graph E. Whenever you have a graph, you can do the vertical line test. So let's once again draw a bunch of vertical lines here. Every time we draw a vertical line, it only crosses the graph one at a time. Only crosses the graph once for each vertical line. So yes, it passes the vertical line test, and therefore it is a function. I'm going to abbreviate vertical line test, VLT, so it is a function. All right, F, vertical lines. Now, is this a function? Well, look at this vertical line. It crosses the graph here, crosses the graph here, crosses the graph here. If that ever happens at any point on the graph, we automatically know that it is not a function. Because what it means is for some input along the x-axis, let's say this is an input right here on the x-axis of 6. You have a y value here, maybe that's like 2. A y value here, maybe that's like 4. And a y value down here, and that's a negative y value, so maybe it's like negative 5. So that input of 6 has more than one y value. In fact, it has 3 output y values. So no, it's not a function. It does not pass the vertical line test. So it is not a function. All right, a couple other vocabulary terms on our first day here related to functions. The word set is a group of numbers we use set notation that looks like a couple of brackets. So that looks like these little brackets like this to group the numbers. Okay, so a set is a group of numbers. Basically, we're going to use little brackets. So a set of numbers could be the domain and it could be the range. Here's a couple of new math words for you. The domain is the set of all possible inputs into our function. So anything we're putting into the function, any possible inputs, called the domain. And then the range, as a math word, is the set of all possible outputs. So the set of all inputs is the domain, the set of all outputs is the range. All right, so let's go through some examples of this. So identify the domain and range for each relation, write your answer in set notation. So remember, ordered pairs have x and y values, so each one is a point that has an x and a y value. And we're not going to necessarily write it in a table this time. This time we're going to write what is the domain and what is the range. We'll look at all of the x values, because remember, the inputs are the x values. So what are all the possible inputs? What are all the possible x values? Well, I see an x value of 1, I see an x value of 3, and I see an x value of negative 2. So that would be the domain, 1, 3, and negative 2. All right, range, all the possible y values, all the possible outputs. What are the possible outputs? Well, I see a 4, I see a 5, and I see a 7. Those are all of the possible outputs. So that's the domain and that's the range. They don't necessarily have to be in order from least to greatest. You can just list them. All right, next group, domain would be, I see a 0, I see a 4. So again, I'm looking at the x values here. So every x value is a part of the domain. All right, and I see 4 again as another x value. So the domain on this one is just 0 and 4. I don't list the 4 twice. I just list it once. So I'm just asking, what are the possible x values? Well, 0 is a possible x value, and 4 is a possible x value. All right, range. Possible outputs are the range, or the possible y values. So we got 3, we've got negative 3, and we've got positive 2. Those would be the range values. What about in a linear equation? So on the front side, we kind of graphed this. So linear equation, we have a y-intercept of 4, So I'm just going to estimate that a slope of 2, so you're going to have a graph that looks something like this. All right, what is the domain? Well, is there any possible x value? Remember, this is the x-axis, this is the y-axis. Is there any possible x value that I could not put into this equation? Is there any x value that's off limits for me to put in here? Can I put a positive number in here? Yes. Can I put a negative number in for x? Yes. I can put any number I want in for x. Therefore, the domain is all numbers. All real numbers, if we were getting technical, but all numbers is what we'll just leave it at for right now. Now, the range would be all the possible outputs. Okay, so in other words, all the possible y values. Was there any y value that eventually this line will not reach? Is there any y value that it will not reach on the negative side or positive side? And the answer to that is no. It will eventually get to whatever y value you want, 1 million, 1 billion, negative 500,000. The graph will eventually reach that because the line never stops. It just keeps going and going and going. So the range will also be all numbers because there's no possible end to all of the output values. They just keep going forever and ever. Now, on some graphs that's true. On other graphs, you have something a little bit different. So this one that we kind of looked at on the first page here is x squared plus 1, and you had a graph that looks like this. Well, this one has a y-intercept of 1. It never goes below 1. So what does that mean? Well, first off, the domain. Is there any x value that would be off limits? Can I square any number that I want? Can I square positive 5? Yes, 5 squared is 25. Negative 10. Can I put a negative in here for x? Negative 10 times negative 10 is 100. So yes, I can put any x value in here that I want. There's nothing that's off limits. So any x value will work. So therefore, the domain is all the possible inputs, which are all numbers, all real numbers. Now, the same thing is not true for the range on this one. So this is a little bit different for the range. Can you see that in terms of the y values, this graph goes infinitely up in the positive direction here, but it never gets below the number of 1. It never goes below that y-intercept of 1. The graph never reaches the negative numbers down here. So the range would be all numbers greater than or equal to 1. Use that greater than or equal to symbol here because it's fine. It goes through every number above 1, and it does include 1, but nothing below 1 would be possible for the output.